Tonight on Rubber Duck Engineering, we will continue our adventures in writing a compiler, interpreter, tokenizer thing for Wren in Rust. Good evening, Dr. Barth.
Play intro music. Is that the intro music?
I think that was great. I think we should totally... I need a button on my desk that plays the Adam Barth intro music.
It's all air guitar, all the time.
Yeah, random Flutter trivia because it just popped in my head. Very early days of the Flutter project. For whatever reason, the GG button.
Oh no, I remember this.
It was like a thing.
It's like a StarCraft thing. Is that where this came from?
It was a StarCraft thing. StarCraft 2. Twitch was like going crazy gangbusters. This was like 6 years ago. I had a small child. I was, was not, running around or anything. So I was watching a lot of TV and, and the StarCraft thing. And then there was like, somebody made like a Kickstarter for GG buttons. And one of our team members got like one for all the team. And so people had these.
So whenever you land a patch, you have to press the GG button. Hi, Frank. We have a comment from Frank.
Hello, Frank. Nice to see you. Yes. So random Flutter trivia. We had GG buttons. They were obnoxious and people took them home because you could not use them in the office. I had mine on my desk for a while.
It was definitely an open office plan, and I'm sure we were very annoying to all of the teams on our floor.
Yeah. That's the other thing when you're a small team at a big company is that you just sort of get tossed around into various little, you get buried in a little like nook or a cranny.
We have 3 desks here. Would you like to be here?
Yes.
Sure.
Anyways, many years ago. So tonight, we're not talking about this. We're talking about Rust. And
Wren.
we were like 3 patches into a new project last time. And I may have gotten a little bit excited about it and may have taken some vacation and may have written 48 more patches.
Do you want to give us a quick rundown of what you've done since the last episode?
Yeah, I think we can even basically jump.
Just to give context for folks, in case you missed the last episode, Wren is a little tiny scripting language that has an implementation in C. And what we're doing is we're creating a new implementation of the language in Rust, largely to learn about implementing compilers and VMs, and also to learn about Rust.
Mm-hmm. That is correct. And so I actually didn't fully set up my video setup here, so I can't see you at the same time I see the screen, but it's okay. I assume you're smiling. This is Visual Studio Code. Oh, yeah. So when we last left our heroes, I think maybe things were basically tokenizing, or like a few things token. Oh, I think we had like 1+1.
Yeah, we successfully tokenized 1+1, and we were very excited about it.
Yeah, it was like maybe this test could have passed.
No, not even remotely. We couldn't tokenize names or dots or parentheses or anything.
I'm trying to think. Well, anyways, that was a few. Yeah, so I greatly expanded the tokenizer, but actually a lot of the journey was, there was this long journey to just get system.print to even work. Yeah, because I think we had like wired up 1+1, that was all. And then system.print was wired up after that, and that was a total hack. It still is a total hack. That's what we might fix tonight, actually. And then after that, I think I did a bunch of tokenizing. Oh, I added compiling at some point. Oh, we must have done that. And yeah, sorry, it's all getting muddled in my head. I eventually wired up the unit tests. So let's see.
So can we actually pass this test now?
Oh, we can pass like 80. We can pass like 100 tests or something, 80-something tests.
Whoa.
Yeah, so there's like a README now. This is all live on GitHub. But here's this README. Here's the 81 tests that we passed. 792 tests fail.
Okay. But, 10%. That's not bad.
A lot of these are like failure tests or like tests that we're passing just sort of by accident.
I see. Test that this doesn't compile. Check. we got that.
Basically. So I forked the test script to make some edits. And then one of the edits that I did was to add this. It knows how to find my own test directory. And so I've been writing my own tests that are simpler than the tests.
Yeah, I find this is a common pattern when you're trying to build up to something that already, like a new implementation of something that already exists. The test for the existing thing will sort of assume that the basics of the thing are already working. And so if you're trying to get to the basics working, you often need to have much simpler tests.
I actually learned something about doing this time is that most testing systems, as you described, assume success rather than assuming failure. And when you're doing bring up, you need to assume failure. And one of the aspects of that actually is it's really important to have test expectations, which the system did not, because again, it assumed all. And so I built a whole system for doing test expectations, by which I just dump the test failure information into a new directory.
When you say test expectations, what do you mean by that?
So like, this is what, so when you run the testing script, which I had to fix it to make it work better on Windows too. This is all parts of the 40 some odd. Those are just like build warnings. Those will go away in a minute. So this is the testing script going by. And you can see it's sort of trying to tell you what's going on down here, but just everything is failing. This is not normally you would just see this little line, slowly going up at the bottom. Or that's what the author of the script expects to go on.
I see. It does expect to spew like thousands and thousands of failures.
And so like I have it print at the bottom all the things that pass because it was expecting all. Now I'm only expecting a few. And then each of these things gets printed out into a file, which is really important because then you can grep those files. You can see how they change. Because
do you do diffs on them? Like do you say like, okay, my current state is that they fail in exactly this way. And then when I edit the project, then I run it again and I see the diffs on the failures.
Yeah. So like, I don't know why these are changed because why are these saying? I don't know. I think this is because I have a stash, and so it's gotten all confused. But yes, so the changes to the files then get checked into Git as I go.
I remember using this approach on the HTML5 parser, where at the beginning we couldn't parse any HTML, and so we had a bunch of like tests that were supposed to parse things, and they just like parse horribly wrong. And then over time, as we added more and more of the implemented more and more of the spec, then they would get closer and closer to the right shape.
I mean, the whole web was done this way. There's all these test expectations. Anyways, I learned that about this, that it was like, is it like one of those things that in the back of your mind, this is what experience teaches you, right? But then it becomes explicit. It became explicit in this time. So some other early things that I did was I made it so that I split the files out a bunch. So for one, so like main, which used to be everything, is now just, quote unquote, I mean, main is still 100 lines long. It is now just a runner that looks like the official test runner.
So you recreated the sort of Wren library API somewhere internally in the project?
No, I just recreated the test runner API basically. Right. So from a command line perspective, I look like the test runner, which is important for integrating with the harness.
Because the harness is a Python wrapper around the test binary.
Correct. Anyway, so with this, we now, I actually kept a little bit of my other old code here because I still use it. But if you deleted all this code, all the rest of this is just to pretend to look like the test harness. It's not a complete implementation of it. So like different compiler or different kinds of errors return different error nodes or return.
Different exit codes or whatever.
Exit codes, yeah. Which is important for the runner. And actually there was a period of hacking in this, which was just making my test runner behave more like the real one to make some of these tests pass. So
do you want to show us how the system, like the 1+1 print test works, or?
Sure. So let's look at the compiler first. I feel like we should get to the coding relatively early tonight. There is a lot of code to review here, and I think that if folks are interested, they should like look at the GitHub some on their own. But so here's all the tokens we support. You'll see that I've mostly now split out the tokens to be one at a time. I had these fancier tokens earlier. I've just come, like the tokens all need sort of special handling, it seems.
But you still have like Boolean, bool instead of like true and false as tokens.
Yep, because those are handled the same. Those are lexed the same, they have the same grammar. But like the keywords are all different because some of the keywords have different grammar. I have this parse token wrapper, which probably should get smushed into a token at some point. Its purpose in life is to hold a byte range so that the tokens, each of the tokens can know what code they came from.
I see.
This input manager is really still the tokenizer, probably needs to get removed. Its job in life is to take in a source string and spit out tokens. The tokenize function is actually a separate free function, but this thing does all the token making. And it now has some peek functions and some peek check functions. It has one that takes a closure. I don't know whether these are like correct patterns. You and I haven't looked through this together, but almost the entire purpose of this, from my perspective, is to learn Rust. Like, it's less to write Wren and it's more to have something to write a bunch of Rust about. Oh, I keep line numbers now so that I can print errors with line numbers, which is important for the test harness, and also just sanity. We can skip a whole bunch of tokens. We make tokens that include the line number and their source. Different various grammar types. This was actually something really fun that I learned about Rust. I'm probably not quite doing this right. I now know about traits, so I think I could have done this simpler. Instead of having 4 error types for 4 different, I could have had an error trait. But you still with us?
Yep.
This is actually really cool about Rust. So Rust has this neat thing where you put a question mark at the end of the line to like rethrow the error. Mm-hmm. It's not actually rethrowing, it's re-return the result, but it also knows how to convert errors if they have a from. And so this means if I just put a question mark after something that returns a from UTF-8 error, it turns it into a Lex string to code error.
I see. That way you can take like standard library functions and then map them into your own error types.
Yep.
That makes sense.
So in order to be an error type, you have to have this display function, which I don't fully understand what or when it's used, but I kind of implement it. Similarly, you have to have this, which is like a source function, which I think is for like error chaining or back traces. I haven't figured out what it's used for yet. So I don't think it's quite implemented correctly. This is more of probably stuff that should be on the input manager, but it's free functions because that's just the style that is in everything in Wren C is free functions. And my code is kind of a mix between the styles.
So when we were in the green room, you were hacking on a function. Do you want to show us what you were hacking on, or like where is the like leading edge of development of this project?
So the thing that I really want to do tonight is so if I unstash my changes, I have no idea what this is going to do. I'm really scared by it showing me changes that I think are not actual changes. Let's try reopening this and see. Well, we'll just try it. Yeah, see, now these are all going to be, yeah. So how do I discard all my changes?
Those discard changes. It's sort of a scary button to press.
We've done one at a time. So I think if I do this, I think it might have like changed the line endings or something. So now if I get my stash back, just restore them all, please. There we go. All right. Now I have my groove back. Snarlax found his groove or whatever. Now you will see the bleeding edge of development when the Rust analyzer, compiler. I don't actually know how this works.
Once it finishes contemplating the universe and your code.
Yeah, it's going to be mad at this code right here, or it should.
Register core primitives. That sounds like an important function.
Yeah, so the Wren thing does relatively cool system. You Wren core this thing. I think we showed this last week. This is this.
This is the like core library, but expressed in Wren.
Correct. Automatically loaded into every module. So whenever you do use any Wren, it just like auto loads this first. A little sketchy. I guess there's no namespaces in Wren, and you would hope that this is very big because it's going to, have some initialization cost. But then there's a C component of this as well. So Wren core C, where there's all these
Oh, it hangs a bunch of operations and such off of those declarations.
That is correct. And so the way that dispatch was hacked into our system so far, this last week, was this cascade used to be in the like call function. But really, these all need to get registered.
And how do you register them?
Well, we have to type code. So what what this big patch is doing, if we go look at this patch, so what is motivating this, is that I'm trying to get the Mandelbrot example to parse and run. And the next thing on the list is a for loop that has a range inside it.
Can you show us the Mandelbrot example?
Mm-hmm.
You're on line 6, basically.
I mean, I tokenize the whole thing. So if we go, this thing, it might actually compile. I guess, it actually should compile, but it's not going to run. But why do we have problems? No, it looks like it did. What? Aborting due to 70 previous errors.
Yeah, this function is total. The function you're in the middle of writing does not compile.
But I don't understand why the Wren thingy doesn't show me that. I don't know. Do I tell it to restart? I don't know.
You may have gotten confused when you stashed all the code. If you try to like edit it, there you go.
Okay.
Get stash when it puts your files back in. I think it doesn't touch the M time somehow, or somehow the M time changes are not what you would expect.
I see. So I was just in the middle of making this thing work, where this needs a semicolon, mismatch types. This needs to be mutable.
You probably need to probably need to borrow it here.
I need to borrow it. Yep. The reason why I'm making this a free function is this is going to end up in another file. Mismatch.
You borrow it mutably, right? I would guess.
Yeah, fine. I learned this about Rust too. Turns out you can now have cargo public. I haven't actually started using it yet, but I thought I paid
crate public means like visible within your crate, but not outside your crate.
This is a problem. Uh-oh. Okay, what this is teaching me is never ever use git stash. At least not with Visual Studio Code.
I think you just want to close compiler.rs and read it back from the disk.
Okay. Let's try and hope. I think it's this thing. Yeah. Okay. I had already made it pub. Okay. We'll get back to that in a second. So, okay, yes, this file doesn't compile anymore. So we could do this. Do this.
This is my favorite way that Eric writes code. Is he just writes the code that he each line of code he types is correct, and then the compiler will tell him what is wrong with the rest of his program, and then he goes and fixes that, and this iterative process eventually converges to a program that does what he wants.
I think this might actually be why I like Rust and why I like Dart.
Because it gives you a lot of errors. It's really telling you when something is wrong.
I just like to lean on the compiler. I like that style of programming.
It works well with these very interactive compilers. Like when you used to have to go to the command line and get a dump of errors, look up the line number. It's not nearly as effective as just clicking through these.
I lost my context as to where we were.
So you were in the register core primitives function at the bottom of this file, and then you just commented it all out.
I could also just make it work. It's kind of the episode. Unless there was something else we were showing.
No, let's do it.
Okay, so we have to devise a method. a way to register these. So I know how it's supposed to work in Wren C. So the way method dispatch in Wren C is a little weird. They're doing like a space-time trade-off, whereby which they have a central registry of all symbols, which does not include the like class name they're being called from. So like, for example, the ... symbol would be ... open paren underbar close paren, because the underbar means it takes an argument, and there'd be like common underbars if there were like multiple arguments.
So like this thing here is plus, is it unary plus?
No, this is not unary.
Well, binary plus, because
binary.
The receiver or like this argument is implied, and it takes one more argument, which is the other side.
Correct. Whereas this one is actually magical, sort of magical, because it's like the only unary operator in the entire system, or one of very few. But yes, this is unary minus.
So you need to register these functions globally as opposed to on particular types.
Aha, so you register them globally, and then every type has then a vector of methods, which can be none is like the default type. And then otherwise they have like an object. So they just like splat out this long vector, and you do a lookup in that vector. And if it has the globally registered integer in it, right? So you take your name and you look it up in the global list of method names. You get back an integer, and you use that integer to look up in your local functions method names.
Feels like every object has a vtable containing every method of every object, except a lot of them will be zeros or empty.
It has a vtable that could be up to the size of. It is in fact up to the size of whatever the maximum method ID it actually uses. So like for these things, what they would have to do is they first need to register the name with the VM.
Okay.
And then they need to, using that index, ensure class.methods is big enough, then set the method on the
okay.
I think I have
sounds sensible.
Some of this written, like all the structures should be there. So vm.method names, that's the index. Class object, so we have to like look up the class object for these, but they're all on the VM. So this one is this one's num class, and it has a methods. Like there's a whole bunch more in this change, because this is a change that I've been working on. I don't know, I worked on it last night too. Probably a little too late. I should have gone to bed. But what else is my train of thought?
Well, these feels like operations that we should apply, right? As opposed to you're sort of poking at the underlying data structures, right?
I was just showing you where the data structures were. I'm trying to help both. I'm trying to make
like vm.register method, whatever it is, this thing here. Give you that like an index.
So eventually they're probably macros, but tonight I don't think they need to be. We're just going to try and like make them work.
And then we're going to say like, what do we have to do? Set the method to what?
We need to first make sure that it's big enough.
Okay. And then somehow we're going to pass in a closure, which is this code.
It's not exactly this code, because this code was working on the stack directly. And now we are passed in, where is it? It's going to be prim. So this is like this is like the macro-y kind of stuff that we'll get to that.
Okay. So what is do you have num plus coded up somewhere?
We're just there in line. But if this thing, here's a primitive function. So we can change how this is. But the way that the dispatch currently works, I could show you that. Call So this is the way call is now coded, is part of this patch. Previously, it was that long if cascade, right? So, but we're replacing that with this dispatch. So first we take the signature that the call is carrying, and we figure out what the actual number of bars are, which is one more than the signature. We figure out where this is, which is that back from the stack. We take all the rest of those. Those are now the args. We just did the whole pop. Whether we should do that or not, I don't know, but that's currently this is coded. And then we, using that class object, we first get the class object, and then we look up the symbol if it's got it, and then, or sorry, we get the symbol name from the VM, right? Because it's the giant table of method names. We look up based on that symbol name, and then we dispatch. There's a few other types of methods that we're not implementing right now, like foreign function calls, for example, which are when you call out into the API side, the C side, not the built into the engine. And then
so okay, that makes sense. So back on the bottom of this file, it feels like we want to say set method index and then num plus.
Sure. Sounds good. And then this gets turned into a num plus method.
We have to write
we can make these closures for now. I don't know whether that's easier or harder.
Why don't we just write them out explicitly? Like, do you want to? What is the signature here?
Okay,
so let's turn this into num plus. Okay. And then I'm going to get 2 arguments now.
You're going to get.
Where do I get the? I think
you're going to get 3. You're going to get this. This is going to be 0. Unless you think you shouldn't get past that. I don't know what Wren C does.
So I'm going to say like, okay. Oh, I have to.
Do you think you should get past this or not? I think you probably should be.
I think you probably should be, right? Like,
I
mean, given the way that the method signature is set up, it feels like I would expect the arguments to be the things that I specified here.
Do you want it split out? Do you want it like be like that? That's trivial for me to do.
I think so. I don't know. Like, we could try that.
I can easily make that work. Let's write the code how we expect it to work using my coding pattern, right? So change this function here to be what you want.
So I want to say like, do I have to check args? Like args dot length. In this case, it's going to be 2, right?
You don't have to check length.
I'm just going to assert it somehow.
Because dispatch already did that for you.
I'm just not going to check it. I'm just going to say like, let left-hand side equals args 0 to num. And then I presume that can fail.
Try into num, but yeah. It's try into num, but yeah.
Try into, does that actually exist?
Yeah.
Oh my gosh.
So it's all worked, right?
Okay. Then I would return okay value from num.
It's just value num. Its value is an enum.
Okay.
That works.
Okay. Awesome.
I think this is maybe like this, and this is, whatever value or right-hand side is fine. I think we call it other in the.
We don't need this anymore. Okay. All right, so now we need to do these 2.
Yeah, both of which should be straightforward. The register method already exists, or like there's already a.
Okay.
I'm trying to think. The compiler, I think, has to do this. Somebody does this. Maybe not. Oh, it's they do. It's just not called methods. The name table is not called methods. It's like method names or something like that. Wren VM. This thing. What's it got?
Method names, maybe?
Method names. The question is, who calls method names? What do they do with it? VM. Ensure method symbol. This thing.
Oh, okay, that looks right. And it returns a usize. Perfect.
Yep. So that's
Method symbol. Okay. It's cool that you have all this stuff written already. So then you have a way of setting a method on a class?
Originally, I was sort of changing it more as I took it over, and now I'm just mostly translating it to like 10-year later code. I'm not changing the method names very much because it's so useful to be referencing back to something that works.
To compare with the C code, you mean?
Yeah, and then I can once it's all passing, I can tear it all to shreds.
Yeah. The power of F2 rename is
Yes,
quite
very
strong.
Ensure methods, yes. Do I have set method? No, this is novel because methods was added as part of this. So this has to, this also probably needs to get wrapped, right? This is method.
I see, because there are other kinds of methods.
So this has to, this is actually a thing that should take a class, basically. Right, because normally you don't get it off of the VM.
Okay.
Right, because I think what this ends up looking like is like VM.register primitive, some sort of helper, right? Primitive takes the name.
And the class or something.
Yeah, maybe the class is first actually. VM num class, so it reads like normal people code, and then function. And then this thing does this. Right, I just need to. I didn't want to stop you. You can go ahead and keep typing.
Yeah, I think you're going to need the VM.
Think I'm going to need the VM? Okay,
Yeah. Method symbol. Yeah.
But then will I be able to borrow both? I can't borrow the num class then. I could clone the num class. It's like
this
is where Rust fights you. What?
Yeah, because you want to pass both the.
If you want to make it general, you want to pass both. You maybe could. Well, I guess we just do it this way. Like we can just start with copy pasta, and we can make it better. There. Right? We'll just see if this works.
Yep.
But we need a set method. So obj class needs a fn set method, and this is a usize method ID. What is it called? Symbol or something? Symbol size, and then method, and it can take ownership of it. I haven't fully wrapped my head around like what's on the stack, what's on the heap. I mean, everything's on the stack in Rust, but that's like a thing that I'm getting used to. Not quite everything. And this needs to do self dot. Oh, I need self, don't I?
Yeah, you need like a mutable self. And I'm not sure what the.
How do I make it big enough? Oh, I want like a fill.
I'm picking that up in the Rust docs. There's like resize.
Yeah.
Yeah, resize. Just give
resize
you
width.
Resize width will give you function callback. We just want resize, which will let you pass in a value.
Okay. So this needs to be, this is like if symbol is greater than self.methods.len, greater than or equal, right?
Mm-hmm.
And then do we want it to be symbol +1?
Yep.
Method none. And we want self.methods symbol equal to method.
Okay.
That exists,
acceptable.
but its traits bound are not satisfied. Clone. What can't be cloned? Method can't be cloned?
You just have to declare it as clonable.
Well, do we want it to be clonable?
Well, if you put it in a vector, you're going to have to, because when the vector grows, it has to copy over the new stuff.
Okay. Find signature in the scope. Yeah, fine. We're gonna just turn these off for a second and see if move out of index. You own this. Like this is your args vector.
Mm-hmm. Right, but it's getting destroyed here. Like you want to, how do you like take apart a Rust vector?
Because try into num eats it? Yeah.
I think you want to like pop or something, like pop, yeah. Oh, pop is an option. You want to like take it out of the vector, right?
I think there's a take. I think you want args.take. Or pop not an option? That's an option. So you want let other equals args.pop. So it's basically the previous code. Okay.
Yep.
That's fascinating. That needs to be the other first, then this, because others. I wonder if passing in the args like that is the right thing.
You want to just unwrap
The
this.
error.
There is an error, right?
We don't need to. The previous thing was
You
doing.
told me that it was always the correct size.
It is, but why? This one was working before. What did I have set up? How did I?
That was your stack, right? You were popping directly off the stack.
Oh, and the stack has a runtime error. VM. Yeah. Okay. We'll leave unwrap for now. It's probably not quite right. This just feels not quite right.
It feels like backwards, right?
How should this? Like, should we have a slice? Should try into num just not simply consume the value? Like, it doesn't need to.
And what I kind of want to write is let this other equal arg, right? But I'm not sure exactly how to do that.
I believe destructuring assignment is a thing.
Right, but so can you destructurally assign a vector?
I don't know.
Let's see, structure assignment.
If not, can we pass a tuple or a slice or whatever would support destructuring instead?
I'm not sure. It's
Do we want a macro here instead? I mean, that's a journey I've not been down with Rust.
a macro.
Well,
I think this is probably fine for now. Like, my guess is that your dispatch, like wrapping all this stuff up in a vector just to unwrap it here, my guess is there's a more efficient intermediary way of getting the values through here.
yeah, like initially I started with a slice because you could also just slice the region. I mean, that's the way that the C version worked. It just takes a pointer. It's like, here is the start of your args. So it just starts an arg pointer. But that's not Rusty, though.
Well, you can just pass the actual stack, right? If you just pass the actual stack, then this thing could pop it off the stack itself. It's a little dangerous, right? Because it could mess up the arity.
Yeah, I mean, we don't have to really defend ourselves against this code. This is like part of the VM code.
Mm-hmm.
Anyways, if this compiles, I think we could try it. Cannot borrow RC data as mutable. Deref mute is required. Okay, so we have to add deref mute. This is the first time I've ever done RC, so I don't know.
Yeah, I'm much more familiar with ARC, which is the atomic version.
I think they should be the same. I think they have the same API. Do they not?
Oh, I don't know. I've never used RC.
I don't understand.
I just think it's part of a trait, right? You probably just deref mut.
No, I think it'll do it automatically. I think we just have to
import it.
Implementing the ref for smart pointers by mutating the data behind them convenient. Should only be implemented on smart pointers to avoid confusion.
Oh, ref cell. I think you need a ref cell.
What the heck's a ref cell? I've seen it, but I didn't understand what it was.
Yeah, so what's happening here is because your thing is reference counted, you don't know who else has a reference to it.
Mm-hmm.
And when you want a mutable reference to it, which means you need exclusive access to it.
Okay.
So you need to make sure that no one else has exclusive access to it.
Sure.
And so normally if you're not using ref counting, the compiler will do type checking to ensure that's the case.
Sure.
So here you need an object that will do that dynamically. So if you're wrong, it'll assert or crash your program.
Okay.
And so ref cell, I think, is the type that will do that for you.
Okay.
So if you're using ARC, we often use a mutex there because what you end up doing is locking the mutex because you could, your reference counted object could be referenced for multiple threads at a time. And so you need an actual mutex to make sure that you're the only one that has exclusive access to it.
Shareable mutable containers. Okay. This felt, I admit I didn't like read all this docs quite. So like a borrow mode?
Yeah, I think it's very common to put a RC around a ref cell, just like it's very common to put an ARC around a mutex. In your program, you're only single threaded, so you don't need a full-on mutex to.
Well, I mean, and part of this is also just a total hack because like this all gets rewritten at some point. I was just trying to get to something that I could imagine, passing around. Like I need to be able to point to the num class in multiple places, right?
Yeah, it needs to be ref counted, but I think you just need to put a ref cell around it. Should we try that?
Sure, please. I'm not entirely sure what you want typed.
Oh, I'm just here on line 102. I'm just going to put in ref cell.
Okay. I don't fully understand what that does.
So the thing you're reference counting now is not directly the object class. It's this cell wrapper that will basically enforce at runtime that only one person has mutable access to it.
All right. Great. Add standard cell for you.
I think you need standard cell colon ref cell.
So,
And wherever you create these things, you probably have to do a little bit more work.
okay. Mismatch types. Expected object class found ref cell.
This
is for- Well, so this is does my class object? I don't know where you are.
I'm on line 154.
Okay. Yeah,
I
that's
just
fine.
added more ref cells.
Those look lovely.
Yeah, so we end up defining, in the part that I'm working on, we end up defining a type that encapsulates all of this, which we would call like a handle, like object handle.
Ugh. Okay. Mismatched a little bit. Too many. Okay. So now when we get these out and put them in the actual classes.
So what does the class object have?
This is just the
The same thing. Whenever you have RC object class, you're going to have ref cell.
Okay. I clearly need to do some reading. Same thing here. No, what is this? Let's see. Are you doing it?
Yeah, cover it.
Ah. That's quite ridiculously ugly. Okay. This class objects thing is defined on object.
I just have a search word. I can just go put it all in. It's easier to understand in the multi-threaded case where you need a mutex.
Okay. Yeah, I just think by the time we get to multi-threaded, this is all going to have been rewritten. So
yeah, for sure.
I didn't bother with arc. Because Wren is actually all about multi-threading, I think. Like it has these separate execution contexts it calls fibers, which it even exposes in the language. No field methods on RC cell VM object. So this no longer is transparently.
All right, so you probably need to borrow. Like what are the operations that ref cell has? Now when you enter the cell, you have to tell it how you want to get into it.
Okay. Done. Borrowed. Did that work?
Yeah.
No field methods. Oh, whoops. Okay, that worked. Name set method. Okay, so now we need to do.
Now you can borrow mutt, which was the point of all this. And now if somebody's borrowing and somebody's borrowing mutt, then your program will crash.
Temporary value dropped while borrowed. Creates a temporary which is free to still use.
I think you need to capture it into a variable.
Okay. Let us weird typing in Wren, which does not have semicolons, and then typing in Rust, which does. Okay. So we think this might work. Oh.
What is this warnings? That's never used.
I'm just trying to remember what this is, but okay. Great. So we're now trying.
So all we have is plus now. So
that's fine. We have we could just do we can just change this to be 1 + 1, right? We don't even have system print, which is a problem. Yeah, this actually isn't going to work. We're going to need to get system print back.
Okay.
And then we can do this.
So we can register print on system somehow.
Which is exactly the thing that it's complaining never uses, this prim system print.
I see.
It's not quite the right signature, but we can fix it.
So is that in the list of things that we commented out? Yes.
Yes. That was the very first one of these that I ever wrote. Was prim system print.
Well, should we do it?
What is that? Are you doing it or am I?
Go for it.
Okay. So we need this.
This, by the way, answers the question about how to uh, abstract this.
What do you mean?
Because we'll borrow mutt is something that we can then pass independently from the mutably borrowed VM. But once we have two, then we can factor the common code out.
Okay, so that's this, and this is prim system print. It's going to be sad that it's the wrong type pattern. And this is not on the num class.
Do you have a system
on
class?
the system class. No, but we can make one.
I'm sorry. I don't know why I enjoy this. Watching you do this coding style so much. It's so different from the way I do it, but it works. It's so effective. I should try it sometime. I don't feel like I have permission to like type code that doesn't work because it angers the compiler. And like, I don't want the compiler to be angry at me. Like,
I feel like you and I have had this conversation for a decade. But
I know, and I still haven't tried it. Like I don't know. I have this mental block where I don't want the compiler to yell at me.
Oh yes, this is the way I live. Okay, so this needs to be a system class. Why is this? Oh, I bet system class is whatever. Okay, now it's like some of it is that I also don't like have all the key bindings in my head, so I use the compiler to get around. Okay, great. This is what we wanted in life. We want this thing to tell us. Oh, that's because it is like literally, as that comment says, the original is not actually written in C. Okay, so you tell me this. Why did we pass the VM to this? Because we think we're good.
I feel like once you do a few of these, you'll tighten down the function signature. You have to pop the value off the R's. I think you want to just be passing the stack in.
These. I mean, I can also just use the stack out of it, but yeah. Okay.
Oh, you don't necessarily want into num, right? You seem to be able to print all kinds of things.
Yep. Into num will it returns into a float anyways. Whatever, an F64. Use of partial. What does that even mean?
Oh, this is what this mutt thing was about.
I'll just take a reference instead, right? Stop it from being moved, because Match doesn't care.
Makes sense.
Mandelbrot is not what we wanted. What is that?
That's the parse the Mandelbrot. Gave you all the tokens.
So now we should be able to do cargo run test bring up add. And not found. Okay.
So the registration wasn't correct somehow?
Well, I wonder what our lookup is. I think we have to like
So you still haven't figured out the debugger.
what are debuggers?
Oh, I mean,
no, I have not figured out the Rust debugger. I installed LLDB or whatever it is, and it just, oh, interesting. We got all the way past and we died here. So we got the this class. Oh, that's why. The reason why is that the system class is registered as just a random number. We look for, oh, I think it was just there. Where is it? It's like somewhere, I just like.
Is the issue that this is a static method instead of an instance method?
I just like search for, I just remember I just made the system class just be like, it's the number 1.0 somewhere. This thing right here. This is not.
Oh, but it's not a variable, right? It's a class. Is this not a class method? It's supposed to be like a class, an object?
Yes, so this thing needs to, I don't know what this is here. Remember, because the way that this used to work was that the dispatcher,
It just cheated, right?
It just cheated. It was like, I saw the string print.
Right, but I'm asking the question whether Wren, the language, has static methods.
I don't remember.
Because the way it's written, it says like system with a capital S, makes it sound like if system is a class, is system an object or a class? I guess is my question.
That's a good question. I mean, the way our dispatch is going to look, it's probably an object. But I actually don't know. We should just look up what. I mean, I can just go look and see what the. But I really don't know. We're also running kind of short on time.
So it's clear from Wren core.wren that system is a class and print is a static method on the class. Because we look at line 441 of Wren core.wren.
So what you're saying is that I don't know how to do class object dispatch.
Possibly. I think you should. Yeah, you need to have some way of having a class object. Like class is part of your first class objects.
I think what I would do is I would hack here, like because the CL is already quite large.
Okay.
I would do something whereby which. Oh, you know what we can do is we can just take our thing here and just put it at the front, basically, of our call.
If it's print, then do this instead.
Yeah, if it's print or if it's any of the other ones that we need to like hack this way. And
now you have the old signature on this, but I guess you can just.
We can also do it the new way, right?
You should do it the new way.
What is it? Let args equal
Vec
self dot stack dot split at
split off. I mean, you should just do it lower, right? Like you do all the work, right?
You are correct. Just do it like down here. No, we don't want to do any of the like lookups. This. Okay, great. Okay, so this thing. How does it do it? VM args.
These things.
Can't find value VM. Well, that's self. Term function.
You need to like. That looks good.
I just return. Okay. Oh, no, I don't return. Can I break?
Sure.
Or is that going to break out of the loop? I don't know. How do I get out of this?
You put the rest in there. Just put everything else in an else.
Okay. The hacks will continue until morale improves.
I don't know why I didn't follow format.
You just save the format. That is.
Oh, okay. Save the format. Format and save. Very good.
There we go.
P5. Hey, success!
So we successfully now have addition dispatching through function level dispatch, and we have.
You need to distinguish between registering static methods and registering instance methods, and then having objects for the classes, etc.
Well, the reason why I didn't want to try and go down that rabbit hole now is that it probably unleashes like a whole section of the VM that I haven't written. And so I just wanted to...
Yeah, get to victory. Get to the point we can raise our arms and say, success, we did it.
Yeah.
1 plus 1, in fact, equals... Oh, wait, no. 2 plus 3, in fact, equals 5.
Yeah, no, so I think it's hard possibly for the viewers and others who haven't, spent quite a few hours in the last, whatever. I spent a lot of this weekend, hacking on this. This is actually a big step to move from static dispatch to object-based dispatch, because we're close. First of all, I can now create a range object, right? I couldn't have objects before at all. So I can now have range objects, which means that I can now implement that for loop. Because I already implemented while loops. Those took a little while, but I did them.
Well, I mean, dispatch is the heart of any VM. Like, you often design your entire language around what is your dispatch strategy for a method. So it's super interesting to see it like up close and detailed like this.
Well, in this dispatch strategy that we hacked out is slow and like it's much more optimized on the Wren C side. But again, I'm trying to avoid the premature optimization. Like, I almost thought about not doing that whole method. Like maybe just shoving a hash table on each of the methods, but we'll see.
Yep. Well, cool. This was fun, Eric. Thanks for sharing this project with us.
Yeah, it's wonderful to see you as always. Any pizza update for the fans at home?
Oh yeah, we made pizza today. We made each pizza was 1.5 recipes of dough, and so they were very large. It's like toss one of them like didn't quite fit in the oven, and so sort of like hung off the side and made a big mess, and it was good times.
Good times. Well, pleasure to see you as always.
Yeah, see you next week.